Okay, I want to start off with some success. So the last time we met, we talked about writing equations with two variables, and master was at 25% and jumped up another 10% after doing a quick little model of annotating. So what has been the impact of doing that quick little model on annotating?
I think the annotations I'm seeing from kids are a lot better. We're spending a lot of time looking at unfamiliar problems and having them annotated first. In today's model, they spend a minute annotating and saying so what is the question asking? What should your final answer look like? And I think that's going to help them be more capable of attacking unfamiliar problems.
Unfamiliar problems, and all of those ones where they have to evaluate in context. Okay, you saw the whole thing, does this even make sense? The second thing, not related to last week, but last year, making equations from tables for writing linear equations from tables was a huge struggle, and almost every single student mastered both question 1 and question 2. Almost every single student mastered question 1. So what are the key moves that you did differently this year to yield this success?
So this year compared to last year, we're annotating the table. There's no assumption that they can mentally find the difference in the y values. Because last year I was obviously they're all adding by 0.6. So having them pull out the calculator, subtract every time, write that's the change in y with the change in x, write the equation to solve for b, no mental math. I think I'm seeing a lot more work this year than I saw last year. And I'm not encouraging students to do it in your head if you can. No,
and
show
I noticed that
step.
in your exemplar too. Last year, this is something we did when we did that 3-table reteach at the end of the year. And so the fact that we're winning this already in, I guess this was October/November, it's a huge win. I'm excited about that. Alright, so today I want to zoom into question 3, because question 1 and 2 kiddos actually did pretty well on. That's directly on your second objective, which is students will be able to determine whether or not a point lies on a line when given 2 points. Alright, so let's go back to your no and do statements. And I want you to highlight for the no and do statements which ones apply to this objective, whether the 2 points lie in the same line. Because half of these go with the first objective, half go with the second.
Well, you got no rate of change, it's the slope, so that applies to it. And then
The problem.
you need to know slope and effect form in order to solve for B. I thought it was longer than that.
It sits in the back.
Definitely this one. Because that's essentially what the question's asking.
I mean, if we're talking about number 3, the whole thing, they need to know everything. If we're talking about, once you have this equation, what's the point that would be on that equation, I think this is the only thing they need to know.
And what about the do statements? What do they have to be able to do, particularly for this question?
You definitely gotta do that. They definitely have to substitute the input, not in this case the x and the y, and determine the b. Write the slope and effect form. Once solved for b, need to know how to take m and b and write the equation. You gotta do that too. I mean, you pretty much probably gotta do.
I would say those are the 3 that I highlighted. So let's roll that back. For the no, what is the biggest thing they need to know to solve number 3? Of the
Rate of
ones you
change.
highlight. Yeah. Of the ones you highlighted, I would say this last one here. They need to know that a point on the graph, I can't read upside down. Can you
Makes
read
a true
that one?
statement. Yeah.
Right.
Point on the graph of an equation. If it makes a true statement, when substituted into the equation. So.
Right. This is the highest leverage thing for them to know conceptually. And then for the do statement, can you read that one?
How to determine if a point is a solution by substituting x and y points into the equation to determine if they are solutions. algebraic. So
Right.
this is after you found the equation, after you've written the equation for these, the point that goes through these 2 points, for the line that goes through these points. Then you substitute these to see if it makes a true
Right, they need to know how to substitute it in, and they need to know, like, if they substitute in those XY coordinates and it makes it true, then those points are also on the line. So that's the do, and that's what they need to, like, understand about that. Like, why am I doing that? It's to see if those points are still on that same line. Okay, so with these 2 key things in mind, let's look at this exemplar. What are the keys to the exemplar?
What's red?
This was an accident. Tamara was printing some kind of warning letter.
I think once you have the equation,
This is like, yeah, you said, once you got the equation, I is to understand that, alright, I gotta try each problem out.
So what is each key move? If you had to talk me through, like, you're solving this from the start, what is each key move you take?
Find the slope. Once you find the slope, take a point, one of the points that they give you is 5, in this case it'd be 5 and 1. You plug in the slope, the x and the y, and solve for b. Once you have b and you have the slope, you write your equation for the line that passes through both. Once you write your equation, you're not done. You have to then go to each point and see if it makes a true statement. So if I plug in -3 into this equation, which is y equals -2x plus 11, do I get 5? So if I plug in 5 and -3, if -3 times 2 plus 11, does that equal 5?
Perfect. And those are the exact same keys that I noted. So let's take a look at my exemplar that I created for this. What is a key difference between my exemplar and the one that y'all have?
I think you're writing the work.
Yeah, each problem, each specific A, B, C, D,
Mm-hmm.
versus we only got,
I wait until I found one that's correct, and then
And where is the work for each one? So this one goes with,
here's one.
this one goes with the first one, and this one goes with the second one.
Yeah, we didn't do the next 2. Well, actually, yeah, we did do here, 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 and we did 3 of them, we didn't.
So that's like a simple thing, like this is not the thing we're gonna talk about as organizing workspace, but it is something that in the future, when you're at progressive monitoring, if you do have the work side by side, and, you know, we talked about earlier, when you're adding in more white space, if you give kiddos more room to do that, it's a small thing that might help, but that's not what we're gonna look at today. Okay, great, so the biggest thing is like solving, each to see if it's completely true. Alright, now let's take a look at Keon's. So Keon didn't write an equation for number 1, but his work for number 3 is beautiful. Let's take a look at Keon's number 3, and how does his exemplar compare to mine?
Wrote the equation. He has y equals x equals m equals b equals, just like this.
Mm-hmm.
And then, yeah, I mean, he's worked his problem out.
And he substituted in and solved to see which one made it true. Perfect. Alright, now let's look at the kids who are almost there. So these kiddos who are almost there, there's a key step missing in their work. There's only 5 kiddos, but there's a key step missing. This is the most common error we saw in kids that got a 2 out of 3. So what is a key thing that's missing between their work and my exemplar?
I don't see.
So in this one, what I see is he just made mistakes. Made a mistake in which was B? Which one is B? -4. You see B? Right here. So this should have been
Positive 8 plus 11.
He's not completely solving it. He's skipping a few little steps in there too. Alright, keep going with the others.
And this one, same mistake. They didn't write the whole negative. It was supposed to be a -2.
They get the wrong slope.
Yeah. Oh yeah, wrong slope. Cause we just went through. Yeah. Wrong slope. This is.
He also didn't completely solve, so even if he had put that in there, he didn't completely solve.
You got the wrong slope.
Wrong slope. correct slope, which I'm, make sure, slope is negative, 2, right? They got the correct slope,
You can see them going all the way through.
they got the wrong B.
Negative
In
3
this
is
case,
about 5.
they should have added 10
Mm-hmm.
right here. And that would have gave them 11, which was the correct y-intercept. Cause they saw, they found that, and they plugged in the y equals mx plus b, which in this case, they should have just added, they subtracted 10 to both sides.
And you can see here, they're like actually solving this. 5 is not equal to negative 3.
Mhm.
I don't see their next one.
Their b is wrong, but according to their b, is it correct?
Yeah, so I actually didn't catch that their B's were wrong. What I did was I looked and noticed that all of these kiddos picked D. All of these kids did. And then went to step backward from that and looked and saw that they all weren't solving completely when substituting in. Some of them like went halfway there and didn't finish the math.
But like this one and this one, their problem's gonna be wrong regardless, each
Because
one,
they didn't put
because they
this
put the
like,
right b in. They didn't have the right y-intercept. So like this one and this one, wrong y-intercept. This one's wrong slope. This one was this computation, they just made a
alright, so let's look back at these then, because I think that it's worth revisiting. So the ones with the wrong y-intercept, because that's the first step, excuse me, the wrong slope. Which ones were those? These
Almost
guys.
all of them. Yeah.
That's the wrong slope. This was, the slope is negative 2,
Mhm.
so that's the
But
right,
they just got the wrong way intercept.
right slope, wrong slope.
All of these guys are the wrong slope.
There's only two. Oh, here's one.
Oh.
Sorry.
There's like, these are all stapled together, those are a lot.
Right slope, wrong y-intercept.
Okay, so we have 3 that are doing the wrong intercept and 2 that are doing the wrong slope. So let's first look at these slope ones. What is the key error kids are making that's causing them to calculate the slope incorrectly?
Minus negative 2.
Mm-hmm.
Should have been a minus a negative 2, that would have gave it a positive 7. And that
Mhm.
would have been negative 14 over positive 7, giving it negative 2. We saw
Same
that.
thing down here. I don't understand how they missed this. They have 14 over negative 7 and they called that negative 4.7.
There's an arithmetic thing.
It's brutal.
Who is this?
Jose.
Oh, he shouldn't have got this question wrong.
Okay. Now,
But these guys got the slope right.
and then why did they get the y-intercept incorrect?
Anyone who got negative 9 subtracted 10 instead of adding 10.
Mm-hmm. But they're not showing their work fully. You can't really see. But in this case, he had 10 and these he subtracted 10.
And it should have been
And
negative 2 here.
yeah,
So because he didn't write the negative.
messed him all the way up even though he had the right slope.
It's arithmetic.
To me, I think that one misconception I'm noticing is that there's so many things you have to do to get to this final answer
Mhm.
that the misorganized workspace actually is fairly significant.
Mm-hmm.
And like, there are several arithmetic errors of like a negative times a negative, or just forgetting to write a negative in the first place.
Mm-hmm.
When we looked at these today, it was
Yeah.
like wrong y-intercept, wrong slope, but then also, you're right, they're not organizedly like going through and substituting numbers in to be like, this is all the way true
And
or
if you
not.
look back at your model, I printed it off, you can tell that too in your workspace.
Mm-hmm.
So it seems like workspace might have helped some of these arithmetic errors organize your workspace.
Yeah, and we turned this is the day we turned into giving a full page for this problem.
yeah, because we took that out.
Because that was off the feedback of more white space.
So
So
we
their
took this
model
out.
problem is like,
Different.
It's like
it's literally this question is the whole page.
like that's this one right here, and then this is the whole page on the next page.
But we're not putting this right next to the problem we're doing it for, typically.
Yeah, I think the key error here is like kiddos are not organizing their workspace and they're not completely solving. They're not organizing their workspace, so they're missing signs and they're not completely solving.
And I think this portion right here helps a lot.
I think
which-
this is key.
This
I agree.
right here is like, which I kind of did on the modified package, like, M equals X equals Y equals B, and we did that today. And that helps you kind of like, all right, I know that my M is here, my X is here, my Y is here. Let me write my equation. So for this particular problem, especially one of these like this is like important.
I think organizing space and completely solving are going to cut out 90% of these gaps. Because it seems like they actually do know the complex steps, which are to solve for slope, to solve for the y-intercepts, to substitute them back in. They're just not completely solving, and they're like not organizing their stuff.
Would there be any value in looking at students who are at like zeros or 33s?
Let's finish this first, and then potentially.
I just feel like a lot of these errors, I'm like, yeah, man, you're just like almost there. -2 times 5 is not 10. So close.
Yeah, I would venture to guess that, yeah, they don't have any work. Well, that's not true. In flipping through them, organization of workspace looks like it's an issue here too. Yeah.
You're in the hundreds right now. They're
Still though, even in the hundreds,
Right,
they're
they're
not
all over the
organizing
place.
their workspace, and so it's really easy to leave out those negative signs.
Instead
and
of
stuff
putting it
that.
like, I know Josh, when you modeled this, instead of putting it right next to it because you have to write so small, what if we like had students do like A, checking A, 19 equals ... Okay, B, I'm checking B, ... like marking off it's not A. Maybe that would be
That'd be better.
worthwhile, yeah.
Okay, so based upon this gap of like students not organizing their workspace and not completely solving, I think those are two big things. And so to teach students how to organize their workspace, is it more appropriate to do a model for this or a discourse and show call something? But you tell me, Josh. Master's 48%.
I think we gotta be more explicit in our model problems every day about organizing our work, and maybe show college students that have flawless work, like more, not necessarily just show calling for the right answer, but show call for like, all right, this is like the way it's set up is right, and that can help.
So I heard you say we need to be more explicit in your model and then show call. And so that's kind of how I would think about it. Like I think for the reteach lesson you do need to model it and be more explicit. And then once you have taught it, then later you can show call. But because you're showing kids like not necessarily a new way, but a more explicit way to organize their workspace, I think you guys should model it.
I think modeling is setting up the workspace. I don't want to model the whole problem because these problems are long.
Yeah, that'll take a while.
So it makes me think like, when I read a problem like this, I want to set up this right away and say like, M is, I need to find M. And I need to find B, and I'm given an X and a Y that I'm going to use. I'm going to write everything I know down.
And I want to write that, and I want to write, change.
I do think it's worth modeling the problem, but I don't know necessarily if we need to have it done Thursday, because we talked about Thursday, but they don't need that to be able to achieve mastery on this week's graphing. The story of the week is graphing.
I do think that if they can answer this problem, they're going to be in such a good place for the Unit 3 test. This is one of the hardest problems on the test.
I agree, and on the EOC. So let's figure out a place where can we do, I think a model for this would take 5 minutes, and then have them do the problem again. Or even just put it on an exit tape to reassess, or a half sheet like you did with first period the other day.
I can tell you that next week's lessons are big, meaty lessons. I know next Thursday's a long time to say we're going to do it then, but it might even be like worth the review and giving like a Thanksgiving break, couple problems that look like this as like keeping this fresh on their minds since we won't have done it in a little while.
I do think it's worth giving like a Thanksgiving turkey packet. We call them turkey packets at KIP NYC, and with problems like this.
If they're doing this, they're in a really good spot. That's kind of what I'd like them to be able to do over Thanksgiving.
And you don't think there's a 5-minute time on Thursday, Friday this week?
We could make it work this Thursday, Friday.
That's what I had pulled up.
We could definitely make it work this Thursday or Friday. Next Thursday, Friday would also work. I don't think any of the 50-minute days are a good idea.
The other thing too with your, so let's pull up Thursday, Friday packets, so we can figure out how we can really make it work and fit.
So 3.7.
Yep. I would say we gotta cut some stuff from the do now. Or
Yeah, we
come
could
on, paper.
delete-
Ah, here it is. Gosh, come on, computer.
We going from the graph to the.
So they're going from graph to function. I want them to do 3 and 4, but we could eliminate 1 and 2.
And make
or
one
ch-
big meaty question.
You could make one into the model you do.
So maybe have them do 3 and 4 first as they come in.
Yes, for their do now, and then number 1, you can kind of do it how you did your model here, but organized workspace.
What is that? I'm sorry. I don't know why this is not.
It's from.
What is? What? I'm gonna have to restart it. Sorry. So the idea being, start with 3 and 4, delete 1 and 2, make 1 and 2 basically a model of this thing.
I would
I
say delete 1 or only do 3 and 4 for the do now,
Right.
and I think you can use this, instead of just asking for the slope, you can say the graph of a linear equation contains the points this and this, which points also lie on the graph. Wouldn't they still be, oh no, this one's asking for the slope, just kidding. Well, you could just definitely do 3 and 4 for the do now. I think that's important, and then add in a question like number 3 afterward to model.
Yeah, no, I'm with you. I'm gonna show you what I come up with here.
Which one you do that?
I'm not gonna do it exactly.
It's basically kinda.
How's this looking? Cool.
Let me see. Mm-hmm. That's definitely more space. I wouldn't make that part of the do now though, just, make it separate, maybe, I don't know if you put like a space in between there. cause right now it looks like it's part of the do now and the kids are encouraged on their own, they're gonna have messy workspace again. And the point that you wanna model, the gap we're closing as students are not organizing their workspace.
Cool.
Let me see what it looks like. Mhm. And then here you guys are gonna have to like script out like exactly what you're gonna say to like organize the workspace. You're gonna be teaching this on Friday, so it'll be really important to like have your exemplar and exactly what you want it to look like, not just the steps, but like how do you want it to be organized on a piece of paper. Cause the kiddos have their work all over the place, and it needs to be really clear.
Yeah, I like the idea, instead of trying to make them write small like yours,
Mm-hmm.
of, I'm gonna show that I'm checking A.
Mm-hmm, yeah.
And then
That makes
here's the
sense.
work for A, and I'm gonna mark off A because A is incorrect. And then, okay, I'm gonna check the work for B.
Why don't you take a minute to actually script that out, especially since Josh is teaching your lesson on Friday. Do you want to type it on there, or do you want to do it
Friday.
handwritten?
Friday on.
Yeah, you will be. Residents are teaching Friday, me and Schulte will be in training.
Oh, okay, cool.
So do you want to type it electronically, or do you want to write it out here? Your preference. Let's do it here, because this is more like what you're going to do on the document camera.
I'm gonna let you go for for scripting this, I think, so. How do you want them to make it look, and I'll do the same thing you do. First hour Thursday.
So we just like all script out, like I was saying, like, all right, well, we approached this problem a week ago. We noticed a lot of people made mistakes because we didn't have organized workspace.
Mm-hmm.
So,
That's the key gap, and it's good you're saying that right off the bat.
Mm-hmm.
oh, I'm sorry, I keep stepping
You're good.
on it. So, first thing I would do when attacking this problem is we have 2 points, and we gotta find the equation that passes through both points, the line. So the equation, and then so I would just go through the steps, and I would say, all right, they gave me 2 points, so I first have to find the slope. So I would do -6. So I'll label my x's and y's. x2, y2. I have -6 minus 1 over, is that a 3? -3 minus 4. -6 minus -1 gives me a bigger negative, so that's -7 over -3 minus 4 gives me a bigger negative, so that's -7 as well. A -7 divided by a -7 gives me a +1. 1 is our A. Now, we have our slope. We also have to find our y-intercept, which is our B, and we can pick one of the points that we are given. So, let's just pick 4 and 1. X is 4, y is 1. We have 3 components of our of the slope-intercept form, so we can plug those in. Y equals mx plus b. And I can plug in what I have to solve for b. I have m, I have a y, and I have an x. So y equals 1 equals 1 times 4 plus b. Alright, 1 times 4 equals 4 plus b. This is a positive 4. Now, we notice that a lot of people, they get mixed up right here. This is a positive 4. There's nothing in front of it. It's not a negative sign, so this is automatically a positive. So to undo an addition is subtraction. We will subtract 4 to both sides. That gives me a negative 3 equals b. We found our b. So, now that we found our m and our b, we can now write our equation, which is y equals m, which is 1, x, b is negative 3, so that gives us a minus 3. This is our equation. We aren't done yet, though. Once we find our equation, we have to then substitute each portion, each point, to see if it makes a true statement. Now, taking it back to what I said earlier, we want to be organized when we do this. So, for A, we're going to try out A. We're going to write out all the steps for A, right next to the problem. To the point. So I'll plug in 1 equals 1 times negative 1
So you're gonna label that A.
minus. Oh, we're going to label A right here? Okay.
I think we landed on that instead of trying to write tiny. You can do
Okay.
both.
You have space in this one. I don't know that you'll have space here. You might be right, like A, check it, B, check
Okay.
it.
So, in this case, I'll write A.
So I know that's the work for A.
This is the work for A.
Good.
Circle. And I plug that in. Minus 3. Negative 1 times 1 gives me a negative 1 minus 3. Negative 1 minus 3 gives me a bigger negative, so 1 it does not equal negative 4. It does not equal. This is not one of our solutions. Let's go to part B. Plug it in. Negative 7.
I'm gonna put B because this is my work for B. That's the gap we want to close, organizing their workspace.
So B, this is our work for part B. So B, x is negative 7, y is negative 7, so I plug in y equals negative 7. 1 times, which is x is negative 7, minus 3. Negative 7 times negative 7 gives me a negative 7 as well. Minus 3. Negative 7 equals negative 10. That is not true, so that is not one of our solutions. I'm going to organize C. This is my work for part C. Now I have negative 1 equals 1 times 2 minus 3. Alright. Positive 1 times positive 2 gives me a positive 2 minus 3. Negative 1. 2 minus 3 gives me a negative 1. I drop down to negative 1. Oh, this makes a true statement. So, that's a check. We're not done yet. We have to try each one because you might have run into a situation where it's more than one answer. So, organize my work for part D. Plug it in. Y is 4 equals 1 times 5 minus 3. 1 times 5 is 5 minus 3. And 5 minus 3 gives me 2. This is not true. Your correct answer is D.
C.
C.
Great. So how is this model going to close the gap that we saw in student work?
It's just going to, it's showing them how to lay out the work, what an exemplary student work should look like.
Right, because the gap was students not organizing their workspace, and we saw that because they were missing signs and they weren't completely solving when they were substituting.
I think one thing I'm thinking for next time when you do this is before you start saying, to figure out if a point is on the line, I need to substitute that point into an equation and see if it's true, which means I need an equation. I know to find an equation, I have to find the slope and this y-intercept. Blank. So given 2 points, I can find the slope by doing the change of y with the change of x. and the y-intercept by substituting in. Just because I think like we want kids to know that like they're gonna get to an equation eventually, which
I don't think you need to show this. I think the way you showed it was clear. I think you should say it. Like, I know that I need an equation because I'm gonna have to plug in those points to see there from the equation.
So you said, so let's just, so like blended two. So like before I start this, alright, originally the question gave me 2 points, and we wanna know which one of these points makes it lies on the graph. That means that it has to be a true statement. And before that, before we know if it makes a true statement, we have to find an equation. We just found our equation. Now we gotta see which one of these makes a true statement if I substitute an x and a y into that equation.
You were talking about it at the very beginning, though.
yeah,
For me, when he was solving for writing the equation, it was very clear.
yeah, I agree. I thought it was clear too. I'm thinking of my low kids right now. In my head, I'm thinking of like Mayana and what is she thinking when she sees this? She gets to here and she thinks she's done.
We got 5 minutes.
Yeah, so I think like the gap we're closing here is the organizing the student work. So I think when you explained like how to get the different parts of the equation, that was clear. If you did want to add any sentence, you could say like, okay, in order to figure this out, I need an equation, and so I'm gonna take the steps to write an equation.
Mm-hmm.
Because by the end, you did have all the parts. I thought your model was perfect the first time. The only thing that I think you need to stamp is the organizing the workspace. A's work is here, B's work is here, C's work is
So
here.
like after I finish, alright, this is what your work should look like. For A, I worked out each step. For B, I worked out each step. C,
Yeah.
this is my work for D.
Yeah. It's
This
what you were
helps
doing
us.
during the model when you got to C and D. Remember for A and B, I had to cue you. For
Mhm.
C and D, you're like, okay, C, the work is gonna go here.
Okay.
How are we gonna reassess this? So you're gonna do one problem right off the do now. You already have an exit ticket this day and a quiz. So, where does it make sense to actually see if kiddos can do this?
You can put it in the quiz.
And the quiz is a CCRS mastery quiz though.
Just do an addendum and have it be like a
Perfect.
response.
So I'm gonna bring you guys this little sheet, and I just wanna see mastery on that one question.
You want it to be the same question?